let's look at a pretty brutal reality for Cambridge IGCSE computer science students. You walk into that exam hall, you write down exactly what you memorized from the textbook, you walk out feeling absolutely confident, and then you get your paper back completely covered in red ink. Today, we're tearing down exactly why your data transmission answers are bleeding marks and how to build a high-scoring strategy specifically for the 0478 syllabus. Zero fluff, zero generic study advice. We're acting as the examiner today to fix your grade boundary right now.
So look at this quote right here. Full duplex is when data goes both ways. You've seen it, you've probably written it, but on a Cambridge exam, that is 0 marks awarded. Grab your imaginary red pen. Why does this fail so terribly? Because it's a generic, floating definition. As an examiner, seeing this tells me you memorized a flashcard, sure, but you have no actual idea how it applies to a network. By giving this kind of isolated answer, you're actively risking your grade boundaries on questions that really should be guaranteed points. Part 1, the red pen disaster, and why ordinary revision fails. The core reason ordinary revision fails in computer science is that the topic of simplex, half-duplex, and full duplex is often taught just as an isolated vocabulary list. You recognize a familiar word on the exam paper, your brain lights up, and you instantly write down your memorized definition. The problem is you end up answering, what does this word mean, instead of why is this method being used in this specific system? And that leads us straight to that dreaded 0. Examiners give 0 marks for shallow answers that completely ignore the actual digital problem at hand. A real computer science question involves a specific device and a practical consequence for the user or the organization. If your answer just recites a dictionary definition and ignores the hardware, the software, or the user's environment, it earns absolutely nothing.
Part 2, 3 layers of understanding, moving beyond definitions.
To stop losing these marks, we need to completely upgrade how you process this information. Examiners actually expect a specific progression when grading data transmission concepts. Layer 1 is your simple explanation. This is just everyday language, understanding that full duplex is like a telephone call where both people can talk at the exact same time. Layer 2 is the technical explanation. This is where you add the correct vocabulary, mentioning simultaneous two-way data transmission. Now, here's the trap. This is where 90% of students stop. They reach Layer 2, they get the vocabulary right, and they think they're ready. But Cambridge exams demand Layer 3, the exam explanation. This is where that technical idea is deliberately shaped to answer the specific scenario, all while under immense time pressure.
And that brings us to the Layer 3 illusion. This brilliantly illustrates the psychological shock that students face. You know the feeling. You sit in your room, review your notes, and think, yep, I know half duplex, got it. But then you're in the exam hall, the clock is ticking down, the scenario is about a highly secure banking system, and suddenly you just freeze. You know the concept, but you don't know how to write it for that specific context. The illusion is thinking that understanding a concept is the exact same thing as being able to execute a written answer.
Part 3, description versus explanation. The fatal difference.
So, the absolutely crucial point here is understanding the teaching discipline of separating what a device is from how it actually works. Let's compare the two. On the left, we have description. This simply tells the examiner what the device or method is. For example, Simplex is one-way data transmission. Sounds super safe, right? But it's incredibly shallow. On the right, we have explanation. This tells the examiner how it works and, most importantly, why it actually matters. Examiners almost always expect both. If you only describe, you strictly cap your marks. But if you jump straight into explaining why it matters without identifying the core concept first, your answer reads as confused. You need both to unlock those full marks.
Now, in just a moment, I'm going to reveal the exact context clue that examiners use to completely trap you on full duplex questions. It's a clue that changes the entire meaning of the answer they are looking for. But first, you really have to grasp the framework that makes that clue utterly obvious. Let's keep going. Part 4. Avoiding the context trap and securing the top band. Generic responses that ignore the scenario are the #1 reason candidates drop right out of the top band. The exam paper doesn't just ask about data transmission in a void, it places it in the real world. So here's an interactive challenge for you. I want you to really think about this. The exam asks, why use full duplex in the robotics control system? Think about the specific wording you would use. Could you answer this right now without falling back on a generic textbook phrase? Take a second and actually formulate your answer. All right, did you come up with something like this? Because it sends data both ways at the same time? Out comes the examiner's red pen again, slash right through it. This answer completely fails. Why? Because it leaves the idea floating in abstraction. It ignores the word robotics entirely. With this answer, you could be talking about a walkie-talkie, a website, or a telephone. There is zero evidence here that you understand why a robot specifically needs this transmission mode. To fix this, you absolutely must apply the concept to the specific environment presented in the question. Real-world transfer matters. If the prompt is about a retail environment, your answer must mention point-of-sale terminals or inventory databases. If it's that robotics question, you need to say that full duplex allows the controller to send movement commands simultaneously while the robot sends sensor feedback back to the controller, which prevents collisions. Your answer must stay firmly inside the scenario given in the prompt. That is how you convert your memory into actual useful marks.
Part 5, the 4-question check, the ultimate self-check framework.
So how do we guarantee you never fall into the context trap again? This framework is simple but devastatingly effective. When you're revising, if you can't answer these 4 prompts out loud for a specific scenario, you are just not ready for the exam. Number 1, what is it? Identify the concept, like half duplex. Number 2, how does it work? Explain the step-by-step mechanism. Number 3, where is it used? Connect it directly back to the exam's context, the factory, the bank, the school. And number 4, why is it better? Justify the design choice. Why exactly is half duplex better than simplex here? If you can speak these 4 answers aloud, you own the topic. If you stumble, you need another revision cycle. Once you have the content, you need the proper sequence. In process-based computer science topics, logical sequencing is literally everything. Step 1, explain the mechanism first. Step 2, state the consequence of that mechanism. Step 3, do not jump backwards and forwards. Mixing general theory with context examples in a random order breaks the flow of your answer. Let me tell you, an examiner trying to untangle a messy, out-of-order paragraph is an examiner who is not going to give you the benefit of the doubt. Keep it clean, keep it linear. And this brilliantly illustrates the concept of real-world transfer. It's all about connecting familiar technology to theoretical mechanisms. You need to remember the reason the concept exists in the first place, not just its label. Students often get distracted by surface features, maybe a fancy device name in the prompt or a weird diagram, and they just panic. Don't let the dressing distract you from the salad. Strip away the unfamiliar device name and recognize the core mechanism underneath. It's just data moving from point A to point B. How is it moving? Focus entirely on that. Which brings us to a golden rule: paraphrase to survive. Error-aware notes that force you to adapt are vastly superior to just memorizing facts. If you can explain the core mechanism of half duplex to a 10-year-old without using your memorized textbook wording, that knowledge is going to survive the panic of the exam hall. If you rely strictly on exact phrasing, the moment you forget one single word, the whole definition collapses.
Part 6, the final hurdle, time pressure.
We've moved past those simple definitions. We've learned to perfectly separate description from explanation. We've avoided the context trap and built answers using the 4-question check. But listen, having the perfect framework means absolutely nothing if you run out of time to actually write it down. You need to translate this deep understanding into rapid, high-scoring bullet points under immense time pressure. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations, and click the explainer on screen right now to master the timed answer writing system before your next paper. But as we wrap up, ask yourself this: when you sit down for your next revision session, are you just memorizing words, or are you actually preparing to solve a digital problem? Don't let the clock steal the marks you just earned. Click the next explainer and let's optimize your writing speed. See you there.